All right, so in a previous video, we had looked at how to use matplotlib and the plt subplots method to create essentially a 2x2 grid of subplots. So I'm just going to, instead of writing all this code from scratch, just kind of go through. You can always watch that previous video on working with multiple subplots in and plt.subplots in matplotlib. It's in the same playlist on visualization with matplotlib and Seaborn. But what we had done is we'd essentially generated a series of x values, and then we created 4 series of y values, one that was essentially squaring the x values, one that was looking at the sign of all the x values, one that was just copying the x values, so it was a line, and then y4, which was adding the two together, or adding y1 and y2 together. And then we had written this code here, so we had a series. We had defined this dictionary where the keys were y1 through y4 as a string, and then the values were the actual NumPy arrays. We had generated a subplot with 2 rows, 2 columns. And then we had went through how to use zip to kind of do that enumeration to where we could get all of that, all of those series plotted with just using some basic code right there. So some basic customization code, which would be applied to each one of those series independently. Right, and this works out fine, as we can see. So this is the code, in case anyone needs to pause right here and kind of go through that. All right, so this was the code. One thing that I did not, particularly love about this was particularly this line right here, right? So not so much the notion that we had to define this dictionary. There's a lot of cases where we're going to do that. We're actually going to do something very similar today. But this, for loop gets a little bit messy. So what we had to do was take, that myplot series dictionary, we get the items, and then we zipped the items with this call to ax.flatten, which gave us back the individual axes. And then we, whatever we were getting back from myplot series.items, we know that a dictionary, when we called that items, is returning 2 things at a time. So the keys and the values. So we're storing the key in series label, the value in plot series, and then that's only handling the first piece of zip. And then that AX flatten, it's returning in this CAX. So it's a lot to it. Even explaining it is a lot. So it's definitely works. And if you're, familiar with Python, it's not surprising why it's working. But it can be a little bit overbearing, especially if someone's not very familiar. So I'm going to show you a different method that you can use to do this with matplotlib that can be a lot more readable, and it actually gives you some interesting functionality in certain cases. So let's look at that. All right. So what we're going to do is we're going to use something called subplot mosaic. And what I'm actually going to do is copy down this myplot series right below. So this is what we'd use. So I've got a dictionary here where the keys are essentially a string name that I want to have for that series. And the values are the actual series themselves. So again, if we just look at this, myplot series, dictionary, right? So the keys are like y1 through, y4 as a string, and then the values are arrays that we would like to plot. All right. So what we're going to do is, instead of using plt.subplots, which is what we used here, we're going to use plt subplot mosaic. plt.subplot, and this is something that I've rather recently found out about, even though it's been, in matplotlib for a while. But let's look at this. So when we were looking at plt.subplots, what we had to do in rows, in columns. The interesting thing is now we don't have those. We have this thing called a mosaic. It can be a string or a list of hashable items, or a list of list, essentially, is what this hashable list is getting at. All right, and here's the way that it works. So we're going to make something called a mosaic. And I'm going to make it a list of list. All right, and in this first one, I'm going to say, well, I want y1, y2. All right, and then below we'll do y3, y4. And the reason I'm breaking this out into 2 different lines is because this is how I want my subplots to look. I want y1 in the upper left, y2 in the upper right, y3, and then y4 in the bottom row. All right, so I can provide this mosaic to plt subplot mosaic. It's going to return two things, just like plt.subplots did. Let's see, what do we have? Oh, so I've got to close off Y4. I don't have my single quote there. All right, so that plots us a region, but the interesting thing is AX. All right, so let me restart my kernel. Let me make this super explicit. Here was our original version with plt.subplots. Right, that worked. Right, but if I look at what AX was, it was an array. So if I look at the type of that, right, so it returned to me a NumPy array, and we had to index. Like if I wanted to get the first row, second column, I had to do something like this, which is not very informative. Even though, we ended up using that somewhat complicated zip, for loop to handle that, it's still, we lost some readability right there. All right, let's look at what's returned when we call subplot mosaic. All right, so now if I look at AX, all right, this looks different. It looks like it's a dictionary, right? So we got curly braces and I've got colons here, so keys and values. And in fact, if I look at the type of that thing, right, it's in fact a dictionary. What's really nice about this is if I look at the keys, right, they look really similar to, the things that we put in that other dictionary, right? Because that's what we defined in our mosaic. We have Y1, Y2. Right, so if we look at our mosaic, that's exactly, it just makes an axis with each one of those. Okay, and if I look at, like, if I grab for Y1, if I say we'll do a .get, it's returning that axis. It's already labeled, right? So that's interesting. Okay, so this is nice, right? So now we've got this dictionary. Well, okay, well, why does that matter? Okay. Well, let's see how we can take that same code that we had before and rewrite it. So I'm going to bring this piece down from our plt.subplots version. I'm just going to put it right here. All right, so here's our call to subplot mosaic. Here was our original code. This isn't going to work. But now what we could do is we could just say for CAX in AX. All right, so that's actually, if we think about it, whenever we iterate over a dictionary, right, we get the keys back. So I'm going to say for CAX label, actually. And then when I'm grabbing an axis, because remember AX is a dictionary, I'm going to say we'll grab the one for whatever is the current value of CAX label, right? And then what I want to do is I could say, well, I'm going to take, as far as the series, well, where do I have that series stored? Well, it's up here in my plot series. And since we named the pieces in the mosaic exactly the same as the keys here, I can just say grab it for CAX label. All right, so that's the change. So for CAX label in AX, I just want to say we'll grab the axis that's corresponding to that label in that dictionary. All right. And then here we were doing our series label upper, where series label was defined in that for loop. Well, now we just got to print the label. And I will, all right. So that's going to run and give us exactly the same code. A little bit more succinct. I feel like it's a little bit more readable, right? Because it's like, okay, well, I know I'm iterating over labels. I'm grabbing the axis for that label. I'm grabbing the series for that label. So I think it can be, quite a bit more readable, a little bit easier for someone to understand, and it's giving us exactly the same result, right? So that's pretty nice. All right. Notice I didn't provide a fig size argument. That's why it's reshaping that, which is fine. I'm just going to let it roll. All right. So some other things that we can do is, what if now that we've got this object, we can actually do some much more fine-grained configuration. So one thing I didn't show previously was, okay, well, this works out really good because we got, a 2x2 grid and we had 4 things to plot. Well, what if we only had 3 and we didn't want to put all 3 in a row? So maybe we wanted to do the first row have 2 and then just put one of them down here with a blank axis. That actually gets somewhat complicated to do, because you'll end up, if you use PLT subplots, it's going to generate, if you say 2 rows, 2 columns, it's generating 4 subplots. So then you have to write additional code to go in and figure out which one has no data and turn that off. All right. Well, we can actually do that really easily here. So what if we didn't have Y4, right? I'm just commenting that out. Well, instead of putting Y4 in the mosaic, we can just put dot as a string. So a string is essentially a period, right? And now when we run that, it doesn't include it, right? So that's pretty interesting. We can also, like, what if we wanted to make this sign series take up a whole row? So maybe we want to put, Y1 in the upper left, have a whole row. So let it span what 2 subplots would in a second row. And then on a final row, have Y3 and Y4. Well, we could do that. So what we could do is we could say, well, do Y1 and then put nothing else on that row. Let's give 2 regions for Y2. And then let's make another row where we've got Y3 and Y4. All right, let me bring Y4 back in. All right, so we're going to have Y1 in the upper left, then another row with just Y2, spanning the space of 2 subplots, and then a final row with Y3 and Y4. All right, so extremely flexible here. Might have to do some more. In this case, remember, so I'm seeing some clipping right here on my title, so I might want to give it some H space, so maybe do a 0.6, and I'm going to bring that W space down a little bit. Let's do 0.4. All right, so it's getting there. Again, I might even want to give it just a little bit more H space so I can differentiate these titles from those horizontal labels, but ultimately it's allowing us to do what we want to do. What if we wanted this one to span 3? Right? You can see where I'm going. What if we want Y2 versus X to span the space of 3, and then maybe have a gap down here between Y3 and Y4? Well, it's really easy. Right? So I'm going to say the one thing is, if I'm going to have any of them spanning 3, well, I need to make sure that they all have that many spaces. So for the first row, I'm giving it essentially 3 directions, right? Just put something upper left, and then the other 2 spaces, just make those empty. Let's have 3 spaces for Y2. And then let's insert an empty subplot in between Y3 and Y4 on the last row. There you go. So a tremendous amount of flexibility. So this is really nice. So I do tend to work with both plt.subplots and subplot mosaic, and I think I work a lot with subplots because I've just done that for so long. However, the subplot mosaic is really flexible, admittedly, so you can come up with some nice visualizations, really kind of lay things out in a nice way. And if you think about it, right, I mean, here's the code, right? So I'm really letting things breathe when I define the dictionary in the mosaic, but I mean, this is the plotting code right here. And I think it's, again, quite readable. So this is a very, very nice method available in matplotlib.pyplot that will allow you to really configure figures that have multiple subplots. All right, so that's subplot mosaic, and that will be the end of this video. In future videos, we're going to now move over to start working with Seaborn, which is a very, very nice library for generating statistical visualizations. So again, a lot of times I'm using matplotlib to kind of control my figures and my subplots, and then I'm using a lot of times Seaborn predominantly to generate my visualizations using pandas data frames or polars data frames. So that's where we will pick up in the future videos.